Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is polynomials. Let us define polynomial first. Polynomial is a Greek word containing two parts. The word poly, it means many, and the word nomial means terms. So polynomial is an expression containing many terms. It has variables, constants and exponents. Here one example is given, a polynomial in y, and it is denoted by p of y. So p of y is equal to 9y cube minus 2y plus 8. The variable here is y and the coefficient of y cube is 9. This is the coefficient of y cube. The coefficient of y term is minus 2. And the term not containing the variable y is called a constant. The constant term is 8 here. You may be wondering, where do we use all these polynomials? Polynomial is a sort of mathematical language where we use basic building blocks to communicate in terms of mathematics. It has got applications in physics, engineering, and even economics. So students, please pay attention here as this topic will be useful throughout your career. Now let us go to the next topic. It is called as the degree of a polynomial. What is degree of a polynomial? It is the highest power of the variable. For example, I have considered here a polynomial in x, p of x equal to 109 x power 4 minus 20x plus 23. So the degree of the polynomial is the highest power. The highest power of x is 4 here. In this thing it is only 1. So the highest power is 4. So the degree of polynomial is 4 for this particular example. In another example where we have taken a polynomial in z, we have defined p of z equal to 13z square minus 3z square minus 2z plus 2 to the power 20. It is important to note that when we find the degree of the polynomial, we should not consider the constant term. So it has to be excluded. Only from the variables, the highest power of the variable is the degree of the polynomial. So the degree of polynomial in this case is 3. Now let us classify the polynomials based on its degree. A degree 1 polynomial is called as a linear polynomial. This is very important. And I have given one example, p of u equal to root 2u plus 2 by 5. This is a constant term and this is a linear polynomial since u has a power of 1. So it has a degree 1. If a polynomial has degree 2, then it is called a quadratic polynomial. This particular polynomial will be studying throughout in this topic and chapter. So here p of x is x square plus x plus 3. Here the degree is 2. So this polynomial is quadratic. Similarly, a polynomial with degree 3 is called a cubic polynomial. Here we see the polynomial has a degree 3. One important thing here, we must always write the polynomial in standard form. By standard form we mean the highest degree should be written first, then the next one and the next and so on. For example, here we have written x square first, then x power 1 and then the constant term. This is a standard way of writing a polynomial. Now, what is the value of polynomial? So far, we have been writing polynomial as a function of some variable. For example, here we have taken a function p of y 9y cube minus 2y plus 8, but it doesn't have a value as yet. So how to define a value for that polynomial? So this is the definition. If k is a constant or some real number, then value of polynomial in x is obtained by substituting x equal to k in the polynomial. Let us try to understand this. We want to find the value of this polynomial at y equal to 2. So we write this as p y equal to 2 equal to 9. Just substitute the value of y equal to 2 in this equation. So 9 into 2 cube minus 2 into 2 plus 8. So p of y equal to 2 is 76. This can be computed. So this is the value of the polynomial at a constant value. So this constant may be defined like y equal to 2, or maybe y equal to minus 2, or y equal to 5, depending upon the requirement. So the value of polynomial will change depending upon the value of k. Now let us find the zero of a polynomial. It is the value of x in a polynomial which makes p of x 0. Zeros of polynomial is also referred to as roots of a polynomial. So we will use these two words as a synonymous. Sometimes we will call zeros of a polynomial, or we may also call it as roots of a polynomial. For example, if you want to find the zero of a polynomial p of y equal to 3y plus 9. So we have to find that value of y which makes py equal to 0. So this is our intention. So we put py equal to 3y plus 9 equal to 0. This gives y equal to minus 3. So the 0 of the polynomial is therefore y equal to minus 3. At this value, p of y becomes 0. Friends, let us now understand the graphical interpretation of zeros of a polynomial. Here we have considered a linear equation to understand the zeros of it. The equation is y equal to 3 plus 3 by 2x. Let us plot this linear equation first. For a linear equation, we need only 2 points to draw a line. So we can consider any points close to 0, 1, 2, 3, or 0, minus 1, minus 3. Let us start with the point x equal to 2. And substitute this value here. So 2 will get cancelled and y will be 6. So we get a coordinate point as 2, 6, which we have plotted here. X is 2 and y is 6. So this point we will plot. Similarly, we will take x equal to 0. So y will be 3. So 0 and 3 is plotted here. Next, we draw a line through these 2 points and extend it so that it cuts the x-axis. At x-axis, it cuts it as minus 2. The point where x-axis it cuts is the zeros of the polynomial. So at x equal to minus 2, y will be 0. Let us check it. Here we have put 3 plus 3 by 2 into minus 2, y equal to 3 minus 3 equal to 0. So at this point, which is the 0 of the polynomial for a linear equation. Let us understand the same graphical interpretation of zeros of a polynomial for a quadratic equation. Here we have taken the quadratic equation as y equal to x square minus 8x plus 12. To plot a quadratic equation, we need more number of points. In the previous example, we have seen for a linear equation, 2 points are sufficient to draw a line. But for a quadratic equation, we need more number of points, maybe 7, 8 points. For example, if we just consider 2 points, for example, let us take or 3 points. For example, 5, 6 and 7 and plot y. We will get only this portion of the line and we may not be able to see the full parabola. So for a quadratic equation, we need more number of points to get full picture of the parabola. From this figure, we observe that once we draw the full parabola, we observe that the parabola cuts the x-axis at two locations. These are the two locations. At x equal to 2 and at x equal to 6. It cuts the x-axis. At these points, we observe that y value is 0. So y will be 0 at x equal to 2 and at x equal to 6. So these are the zeros of the polynomial. Now question comes, how many number of zeros are there for a quadratic polynomial? Generally it looks for a second order or second degree polynomial there should be 2 number of zeros. But this is what we see from this slide is that the quadratic polynomial can have at most 2 zeros. It means it can have 1 0 also or no zeros also. This example has shown it. This is a parabola where we see it cuts the axis at 2 points. So this is it will have 2 zeros. This particular quadratic polynomial will have 2 zeros. Let us check here. This parabola is not cutting x-axis at all. So it has no zeros. Similarly, this particular polynomial or a parabola is cutting the x-axis exactly at one point, x equal to 0. So this particular polynomial has only 1 0. So what conclusion we make? The quadratic polynomial can have at most 2 0. Similarly, we can extend this to say that a cubic polynomial can have at most 3 zeros. Now we'll take a quiz for you students. Here you have to answer the following based on the polynomial. This polynomial is given to you. You have to answer the questions. Like first question is the degree of the polynomial you have to tell. Please take your time students. As told earlier, to find degree of the polynomial we should not consider the constant term. So we must find the highest degree of the variable. So the correct answer is 3. The next question is the constant term in the polynomial. The constant term in the polynomial is 2 to the power 5. What is the coefficient of y square? The coefficient of y square here is 9. Students, please find the value of the polynomial p of x equal to 3x cubed plus 2x square minus 3x plus 5 at x equal to minus 1. Please take your time students. You must substitute minus 1 instead of x in this expression and get p of x equal to minus 1 as 7. In the next question, students please count number of zeros from the figure. If your answer is 2, then you are correct because this particular quadratic equation or parabola cuts the x-axis at 2 points. So the number of zeros for this figure is, or this particular polynomial or parabola is 2. Let us find the zeros of the polynomial. Now we consider a polynomial p of x square minus x minus 12. We have to find its zeros. So how do we find zeros? We have to equate this equal to 0. This should become p of x should become 0. That's what we have done here, friends. We have written it like this. Now how to factorize this? This is little important thing here and you must learn this trick. Now to get factors of this equation, we must split this minus x into two values such that we get a product of, we can put 1 here, we can get a product of minus 12, 1 into minus 12. So product is minus 12 and the sum should be minus x. In simple words, we should split the middle term such that we get a product of coefficient of x square into the constant term which is minus 12 and the sum should be minus x. To get a product of 12, immediately 4 and 3 comes into our mind and the difference 4 minus 3 can be 1. So we should consider two terms minus 4 and plus 3. Minus 4x plus 3x is minus x. So x square and minus 12 terms are retained. So this is mathematically similar to this equation. Now we take the first two terms and take common x. So x is x minus 4. We automatically get x minus 4 as common if we take these two terms. So 3 will be common and x minus 4 will be inside the bracket. We observe that if our splitting of the variable is correct, then we should get two common terms in our simplification. If these two terms are not coming same, it means our splitting of the variable is incorrect. Further, now if this is correct, we get identical expression here. Then further taking common x plus 3, we will get x minus 4 into x plus 3 equal to 0. When two expressions product is 0, then one of them or both of them are 0. That is x plus 3 equal to 0 or x minus 4 equal to 0. If x plus 3 is equal to 0, then friend x equal to minus 3 and x equal to 4. So these two, x equal to minus 3 and x equal to 4, are the zeros of the polynomial. How to check this, friends? Check your answer. Substitute here. Let us substitute minus 3 or let us substitute 4 in this expression. So we will get 4 square minus 4 minus 12. So this is 16 minus 4 minus 12 is 0. So the p of x is becoming 0 if we substitute the zeros of the polynomial. Similarly, we can check it for x equal to minus 3. So these two values are indeed the zeros of the polynomial. If we are given a quadratic equation in standard form ax square plus bx plus c, then it is observed that the sum of the roots, here alpha and beta, are the zeros of this polynomial or the roots of this polynomial. So if alpha beta are the zeros of this polynomial, then alpha plus beta is minus b by a and alpha beta equal to c by a, or sum of the roots equal to minus b by a. What is minus b by a? Minus b is the coefficient of x, and what is a is coefficient of x square. Similarly, product of root is c by a. C is the constant term and a is the coefficient of x square. These are the standard expression which you must remember. So basically we are finding a relation between the roots of the polynomial and the coefficients of the polynomial. Now let us take one example, x square minus x minus 12, and we want to check the relationship of its 0 with the coefficients. Remember, friends, earlier we have taken this particular example and found the roots as -3 and 4? Yes, you are right. And let us find the relation of these zeros with the coefficients. What are the value of coefficients? A is 1. A is 1 here. B is -1. B is -1. And C is -12. The constant term. Let us find the relationship. So alpha plus beta, sum of the roots equal to -b by a. So alpha plus beta is -3 plus 4 minus b by a, -1 by 1. What is this? 4 minus 3 is 1. This expression is 1 by 1, which is 1. So 1 is equal to 1. It means alpha plus beta equal to -b by a. We checked it. Let us check the other expression. Alpha beta, or the product of the roots, is c by a. So -3 into -4, friend, is -12. What is c? C is -12 by a, which is -12. So we verified this expression also. So this is also correct. Now we will be doing a little bit of reverse engineering. Here we are given the roots and we have to find the quadratic equation. Let the quadratic equation be this: ax square plus bx plus c. Then let us divide each of its term by a. So we will get x square plus b by ax plus c by a. We can rearrange this term: minus b by a as minus of minus b by ax plus c by a. Friends, what is minus b by a? Just now we saw these are the sum of the roots. And what is c by a? These are the product of the roots. So in case you are given sum of the roots and product of the roots, the quadratic equation is x square minus sum of the root x plus product of the roots. This equation also you must remember. I'll repeat again. If you are given sum of the roots and product of the roots as some values and we need to find the quadratic equation, then we use this formula: x square minus sum of the root x plus product of the roots. This will be the resultant quadratic equation. Let us find the quadratic equation whose roots are -3 and 4. Let us use this formula. So alpha is -3, beta is 4. So x square minus sum of the root x plus product of the roots gives x square minus x minus 12. This is what we did earlier and got the roots. So in this particular case, we are taking the roots and getting back the quadratic equation. Now we will extend the quadratic equation formulas to cubic equation. Let us consider a cubic equation: ax cube plus bx square plus cx plus. This is a cubic equation in standard form. So if alpha, beta and gamma, please note that for a cubic equation we can have 3 roots. So we will consider alpha, beta and gamma be the zeros of this polynomial. Then we have these relations similar to quadratic. Here sum of the roots is minus b by a. Please recollect that the b value was coefficient of x there, but here b value is coefficient of x square. You can remember this as formulas. Now let us take a couple of practice questions. Now here we are given a polynomial 4x square minus 3x minus 7. Then we need to find alpha square plus beta square, where alpha and beta are the zeros or roots of this polynomial. So we are given alpha plus beta. We remember alpha plus beta equal to minus b by a. So it will be 3 by 4, and product of the polynomial is c by a, which is minus 7 by 4. Please note, if alpha and beta were directly given to us, then we can simply compute alpha square plus beta square. But here we are not given alpha and beta individually. However, we are given alpha plus beta is 3 by 4 and alpha beta is minus n. Now using this information of alpha beta and alpha plus beta, we need to get alpha square plus beta square. You may recollect very simple formula of alpha plus beta square is equal to alpha square plus beta square plus 2 alpha beta. Since we want to compute alpha square plus beta square, we will rearrange the terms and find alpha square plus beta square equal to alpha plus beta square minus 2 alpha beta. Let us substitute the values of alpha plus beta and alpha beta from here into the equation. So alpha square plus beta square equal to 3 by 4 the whole square minus 2 into alpha beta minus 7. This gives 65 by 16 as alpha square plus beta square. Now we'll go take up another question. Here we find the value of k. This is a quadratic equation. Find the value of k for which one root of the equation is 4 times the other. So let alpha be the one root. Then what is the other root, friends? It will be 4. Since it is 4 times, it will be 4 alpha. What information we have now? Sum of the roots is equal to minus b by a. So it is minus b is 5 by k. This we call equation 1. Similarly, product of the root is c by a. So 2 by k is the product of root. So this is the second equation. Now we have two equations in two unknowns. Alpha and k are unknown and we have these two equations. Ideally, we should get the value of k directly by eliminating alpha, but it is not possible to do so here. In fact, we'll eliminate first k and then get the value of alpha. Let us try this way. Divide 2 by 1. 2 by 1 means 4 alpha square divided by 5 alpha is equal to 2 by k by 5 by k. Solving this simple equation, this will get cancelled. So k will get cancelled. So alpha we will get as 1 by 2. Just simplification, please. Then substitute this alpha equal to 1 by 2 in say equation 1. So here k is equal to 5 by 5 alpha. Substitute the value of alpha here as half. We get k as 2. Friends, this completes the chapter for this on polynomial section. Now I sincerely request you to subscribe my channel so that the next videos are posted to you directly, and also my sincere request you to give a thumbs up to this particular video if you find that this is very useful. This will motivate me to make more such videos. Thank you very much, friends.